everyone. This is Dr. V.V.Kamesh, Professor of Mechanical Engineering, Aditya University, Surampalem. In this lecture, we would like to know about the importance of the kinematics of machinery by introducing some fundamentals. At the end of this lecture, a student will be able to explain the fundamental concepts of kinematics of machinery. In general, we used to refer to KOM, kinematics of machinery. So, what is this kinematics of machines deals with? So, clearly, it is dealing with the analysis and synthesis of mechanisms. What is analysis and what is synthesis? Analysis of mechanism, synthesis of mechanism. So, these two are the integral part of the kinematics of machinery. So, before that, we like to know what is kinematics. So, in general, the kinematics is one branch of physics. Earlier, we know in our earlier studies, like in the intermediate, we used to have the physics, kinematics, kinetics, sound, electricity, like this some physics concepts are there. So, in that concepts, we are having kinematics. So, at that particular instant, we don't know what is kinematics, what is kinetics, what is statics, what is dynamics, like all these things. But as the knowledge is increasing, we are having the separation of each and every topics of the physics into a separate branch of study. In the kinematics, we will know about the displacement, velocity, acceleration of a particle or a rigid body, right? So, once you call the rigid body, there will be also some doubt about if the body is not rigid. So, it could be a flexible body, right? In the engineering mechanics or in the theory of machines, we will deal with mainly the rigid bodies. Rigid means, to be frankly speaking, on the earth, we don't have any rigid body, right? So, rigid means simply, suppose I am taking one entity, it may be a plastic, it may be a stone, or it may be something, right? So, the distance between any 2 points concerned on that body, if it is not altered by the external force, that means suppose I will take a stone and I will compress it. So, it will withstand for a certain amount of force. After some time, it will collapse. So, until it collapses, it is called a rigid body, right? Suppose I am taking this pen. If I am elongating like this, right? So, after some time, it will start elongating. So, until then, suppose I am applying 100 Newton force, tensile force. So, applying like this. One end and other end, I am pulling from both the ends. Then it is called tensile, right? Suppose I am applying the tensile force of 100 Newtons. There is, suppose I am taking this is A point and this is B point. 2 points are there. The distance between these points, it may be some 8 centimeters. After applying the 100 Newtons for some time, still it is 8 centimeters. So, it is a rigid body. Now, you apply 1000 Newtons. It will become 8.1 or 8.05 centimeter. Then, it starts elongating. When it starts elongating or deformation is there, it is not a rigid body. So, until some external force is having some limit to be collapsed the body, until then mainly all the bodies are rigid bodies, right? Now, we are considering the rigid body as a particle or as a rigid body. We will calculate the displacement, velocity and acceleration of the each and every particle under the influence of an external force, right? Suppose this body I am holding on my left hand, right? Now, what is the condition of this body? It is at rest. So, no displacement, no velocity, no acceleration. When the body is moving, then the body may have some movement from one place to other place, right? Like I am moving. So, the displacement, how much it is? Okay. So, how much distance it covered is called displacement. If it is having the direction, it is called displacement. If the direction is not a matter of fact, then it is called distance, right? Now, suppose I am moving from one place to other place in a time period of t, then the parameter displacement by time is called velocity, right? So, we will calculate the velocity in meters per second in general. After that, what is the change of velocity from one instant to other instant? Suppose I am having a long distance, some 1 kilometer or 2 kilometers. So, for 100 meters, I am maintaining some speed or velocity. After some distance, I am increasing my velocity, again I am decreasing the velocity, again I am increasing, right? Like this I am altering my velocity. Then I need to calculate for a particular matter of time. It may be for t1 equal to 1 second to t1 equal to 3 seconds, like that. Then I need to calculate the change of velocity with respect to the time. It is called acceleration. So, for any body, when it is moving, I am able to calculate displacement, velocity and acceleration, right? Now, all this will be having, I told you, the body is moving, right? How can the body will move? Either it may be in a straight line, got it? So, from one place to other place. So, this is called, if I am moving in a straight line, it is called rectilinear translation. Now, you can see this. This is rectilinear translation. Suppose I am holding on the one end of this pen and I am moving like this, okay, right? Or otherwise, I am holding at one end, I am turning like this, okay. So, this is in curvilinear motion. Generally, the curvilinear motion we are able to experience even when this is a road and it is a car and you are in the car, you are in the bus, and when it is turning to the left or right, then you are having some feeling, right? So, you are moving to the left, you are moving to the right. This is called curvilinear motion, right? In a plane means when all the particles are in a same level, then we are call it as a plane, right? Other than the plane, we are having the spatial moments that we will discuss later, right? And the rotation of the rigid bodies. Rotation means there is a slight difference between the curvilinear motion and rotation. Curvilinear motion means the total body is moving, a car or bus or bike or anybody or train, right? It is moving, the total body is moving as a whole through a path, in a curvilinear path, right? So, body is moving in a curvilinear path. Now, but rotation of the rigid body. So, rigid body rotating means at least one point of this rigid body is to be fixed. Now, I am taking this pen, right? I am fixing at one end, right? Here the fixing means it does not mean that completely fixing, right? It is constrained, so not to move. So, I am holding like this. Suppose I am piercing one hole and I am putting some nut and screw here or some pin here, so that it will rotate freely like this, okay. So, I am able to rotate this pen with one end is fixed or pin jointed we are calling, and by holding other end or any other end in between. So, I can hold in between, I can hold very near to that. So, it is rotating, right? Got the point? So, this is the difference between the rectilinear translation, curvilinear motion and rotation of the rigid bodies, right? Next, we need to have the scope of theory of machines. So, theory of machines, it is an applied science. So, on which it is applied? Generally, rigid bodies. So, whatever the rigid bodies science is there, so we are applying in our daily life, right? So, I will show you one by one where we are applying the kinematics of machinery or dynamics of machinery or theory of machines in our regular life. So, it deals with the motion of the machines and actions which cause the motion. So, actions which cause the motion, that means what is the motive behind it? What is the motive, or in general language, who is creating the force, right? So, the motion of the machines. So, machines will move in a rectilinear direction, curvilinear, rotation like this, right? So, now we will come to the theory of machines division or classification. So, theory of machines is divided into two classifications. One part is kinematics of machinery, second part is dynamics of machinery, right? It does not mean that kinematics and dynamics are different, right? It is one wing, it is another wing, right? Now, if you want to design a new component, right, or design something, some device, okay. So, I want to create one device, right. So, first I need to go for the kinematics of machinery. So, what we will do in the kinematics of machinery, you look at the slide, study of motion of the components and basic geometry of mechanism, right. So, study of motion of the components means, so initially I will have some skeleton, right. Suppose I want to create a robot, right. So, to create a robot, what I need to have the basic geometry. Generally, whatever the manual work is there, I want to give it to robot, right. So, generally what I will do, a robot will have a head, a robot will have a neck, a robot will have two hands, right. A robot will have some abdomen like this, a robot has to move, so two legs. It is just similar to the human body, got it? So, the geometry of the robot, basically it is copying human body. That is why you are calling the humanoid robots, right? So after getting this one, then I will modify each and every component, right? So the motion of the each and every component, suppose I am taking the head of the robot, right? So how many degrees the robot head has to rotate? Human body cannot rotate 360 degrees, but unlike the human, I can make the robot to revolve 360 degrees. Robot head can rotate 360 degrees, I can make. Whatever the difficulties I am facing as a human, so I want to make it clarified with the robot design, right? Suppose after 2 hours or 3 hours, I will have the fatigue. So I want to make my robot not to have the fatigue. So I will give continuous energy, right? So coming to this components and basic geometry of the mechanism. Here the geometry means what is the shape, thickness. So all these items, it will decide the basic geometry, right? So after deciding the geometry of a particular component, then what I need to do is, here the component means generally we are having link. Link means, suppose you are seeing this robot, this hand is one link, this abdomen, right? Whatever you are seeing like this, it is second link, another hand is a third link, and your head is fourth link, leg one, right leg and left leg. So all these are the links. So this may be L1, this may be L2. So your abdomen is L3, one hand is L4, another hand is L5, neck is L6 and the head is L7. So each and every component in kinematics of machinery you used to refer as link. So I will explain after a few slides, maybe in the next lecture or in the third lecture, I will explain what is a link, right? Basically, each and every component in the kinematics of machinery you used to refer to as link. Now in the kinematics of machinery, what I will do, everybody will do analysis and synthesis of mechanism. Synthesis means creation, right? So how many alternatives you are able to produce? So synthesis. So you can create unlimited designs, right? Suppose I want to construct a building. So many plans we will arrange, right? Finally, we will decide one. So synthesis means creation of alternatives with the different shapes, different styles, right? Analysis means we will call it as kinematic analysis. Actually speaking, it is called kinematic analysis, right? Now coming into after the analysis is over, so at the end of the kinematics of machinery, what is the output? After making so many synthesis, so many designs and kinematic analysis, few designs will be finally gone through. So it may be you created nearly some 15 designs. Out of the 15 designs, kinematically they will get passed only 3 or 2, let it be, right? So 2 designs are with you at the end of the kinematics of machinery, right? So one is design number 1, second one is design number 2. Now we will go to dynamics of machinery. After kinematics of machinery is completed, the output will go to dynamics of machinery, right? If you are creating from the scratch, right? Suppose already the designs are available, you want to make the modification in the dynamics part only. So no need to have the creation, synthesis, analysis, nothing is required. So directly you start with the dynamics of machinery. So coming from outside, there is fixed design. So design is already fixed, right? Suppose I want to create one material for the aeroplane. So definitely it will be an aluminum alloy or titanium alloy, right? I don't take the iron into consideration, gold into consideration. Already that part is over. So the material is already fixed. The design is already fixed. So in the dynamics part only I want to do something, right? So in the dynamics of machinery, what we will do? Study of statics and kinetics of machinery. Here you remember the word kinetics. That means after the application of the force, right, what will be the dynamic moment, right? Here the basic thing is the application of D'Alembert's principle. In one way or the other, it is another version of Newton's second law, right? So we will deal one by one later. So the theory of machines is the stepping stone to, that means what is the scope? The conception of an arrangement of the components, definition of the geometry of each part and working of the system and assembly of the parts based on design details. Now we would like to know, I already told each and every component is called link, right? So you can extend the word kinematic link or element. So each part of a machine which moves relative to some other part is known as kinematic link or element. That means if you are moving your hand, so I am moving my fingers, right? With respect to whatever the human body, if I am moving my hand, so my hand is a link, right? I am moving my leg. Leg is a kinematic link. Leg is an element. You can call, right? So the definition, a link may consist of the several parts which are rigidly fastened together so that they do not move relative to one another, right? Got the point? So here you can, you may have some doubt. What is that rigidly fastened? Rigidly fastened together means they do not move relative to one another. That means I am able to move my hand like this, right? But my hands are already fixed to my body, right? I cannot move left hand to one direction, right hand to another direction more than my workspace, right? I can move a slight distance, here also some distance, right? So, but I cannot move my total body along with my left hand, along with my right hand, right? Only one direction. So, suppose for example, we are taking one reciprocating engine. It is an IC engine, we will call it as internal combustion engine or a reciprocating steam engine, whatever you take, right? Here we are having some basic components called piston, piston rod and cross head. They are constituting one link, right? So, we will explain one by one later. In the initial, you may not understand what is connecting rod, what is big end, small end, bearings, what is the first link, what is the second link, right? So, one by one by one, you are going to understand what is link number 1, link number 2, right? After getting so many classes, right? So, crank, so these are all different links. So, this is the link number 1, this is the link number 2, right? And this total thing you are having link number 3, right? So, this one. So, whatever I am calling this one, right? So, this is link number 3. Suppose I am calling this is link number 1, this is link number 2 and the fixed part is fourth link. So, when we will discuss about the 4 bar link, again the same concept will come again, right? Now, we will like to know about the types of links. So, in the classification of the links, we are having 2 types of varieties. In order to transmit the motion, the driver and the follower may be connected by the following 3 types, right? So, types of links means who is moving and who is following. I told you earlier, we will apply the force or we will apply some energy, right, on one part, right. So, who is being applied is called the follower, right. Suppose I am applying the force at one end and I am observing the moment at some other area, right. So, one is driver and one is follower. In between, I may have so many other components or the links, right. So, the first one is called the rigid link. So, a rigid link is the one which doesn't undergo any deformation while transmitting motion, right. So, deformation means now you are seeing this pen is straight, right. Suppose I am applying the force at one end, suppose it is bending, it is deformation, right. So, deformation means whatever the shape change you are able to observe, right, it is called deformation. So, if there is no deformation, it is called a rigid link, right. So, I already told, strictly speaking, rigid links do not exist. Up to a certain limit only you will have. So, however, as the deformation of a connecting rod, crank, of a reciprocating steam engines is not appreciable. So, it is a very minute one, right. After a long prolonged time, after continuous exposure to the high amount of the force for high period of time, then only there will be a slight 0.01 degree of change, right. It is negligible. So, you can consider them as rigid links. Now, the second one is flexible link. So, flexible link is the one which is partly deformed in a manner not to affect the transmission of the motion. So, generally we are having the belts, ropes, chains and wires, right. You can see the belt transmission, the ropeway transmission, chain transmission in your cycle, bicycle or bike, right, in automobiles, and wire transmission. Generally we used to have the steel wires, right, a long high diameter, okay. So, wires, these are all the flexible links and transmit the tensile force only, right. So, the belts or ropes or chains, so they will transmit the tensile force. So, these are called the flexible links and fluid link. So, fluid link means A fluid link is the one which is formed by having a fluid in a receptacle and the motion is transmitted through the fluid by pressure or compression only. So, the best example for you is, you can see this injection, right? So, how the injection will be done? Taking by some pressure, and we are putting some plunger like this, and the medicine will go into our body, right? Got the point? So, what is that medicine? It is a fluid. Where I am applying the force? On the fluid, right? So, here we are making compression, right? By compression of the fluid, automatically the link is moved. So, in the case of the hydraulic press, jocks and brakes. So, there will be hydraulic brake, you can see in the automobiles. So, this is one type of link classification. Second one will be about the connectivity. So, the link or the element, again the name is same. It is the name given to any body which has motion relative to another. All the materials have some elasticity. A rigid link is the one which deformation is so small that they can be neglected in determining the motion parameters of the link. So, this is regarding the rigid links. Now, even in the rigid link, we are having some more classification. So, this is about another parameter called about the connectivity, right? So, binary link. So, whenever you are having the binary, it refers to two. So, the link which is connected to other links at 2 points, right? Suppose the link is connected to 3 other links. So, this is ternary link is 3, quaternary link is 4. Like this, we can have some more, right? I can create a pentagonal link like this. So, it is having the connectivities at 5 points. I can create a quaternary link. So, this link is, it is connected to 6 other points or 6 links. So, 1, 2, 3, 4, 5, 6. Got the point? So, the ternary link, quaternary link or some more links. So, you can go to the higher level. So, this is regarding the links classification. So, at the end of this, student can explain the fundamentals of the kinematics of machinery. Thank you.